This is not a sales pitch, so I'm not going to bore you too much with this stuff, but just to give you a little sense of who we are. We're a 3-year-old company. We have the great fortune and pleasure of working with Lightspeed and some other great investors, as well as a number of really fantastic customers of all different shapes and sizes. Here's a really nice quote from our friends and partners at Colgate, where we're able to help them leverage AI and machine learning to make their sales and marketing teams way more productive than they were before. And we're able to do so with pretty amazing results pretty quickly. So that's a little bit about us. Personally, before this, I used to run the engineering team at a company called MemSQL, and my background is actually in relational databases. And that, it colors a lot of what you're going to see in the presentation, and also a little bit of how we think about the world. So hopefully that sets us up for a fun discussion. And I'm really looking forward to the Q&A and the discussion afterwards. So let's start by just looking at an example. I'm sure you've all seen something like this. And for better or for worse, documents like this one are everywhere in the enterprise. And actually, a good friend of mine just started a really cool venture-backed e-commerce company that sells medical devices to patients online instead of kind of the antiquated way of doing it. And again, they're a cool Silicon Valley startup. They were founded in 2020, raised a bunch of money, and built a really nice web UI that allows doctors to submit orders for their patients automatically. And everything was going really well until they started working with real healthcare providers. And out of nowhere, they started receiving faxes. And actually, 70% of the orders were sent to them over fax, not the really cool web UI that they built. And that's a pretty common story, whether you're a small startup or a large enterprise working with any kind of legacy partner. No matter how hard we try, we can't get rid of things like forms, invoices, statements, and other non-standard documents. As an enterprise, you want to be in control of how and when you digitally transform, not at the mercy of those partners. And this challenge we've seen is a very massive problem for productivity because the work of looking at documents and rekeying them into Salesforce, it often falls on knowledge workers in areas like operations, sales, marketing, finance, customer service, and so on. So we're going to talk about this example and kind of contextualize it in the broader space of AI and machine learning. But with documents specifically, today most people are actually still rekeying forms by hand. And the crazy thing is that the technology to solve this problem exists. And in the scheme of things, it's actually a pretty easy machine learning problem too. It just is super painful to implement. The enterprises that we talk to are months or nowadays sometimes years into RPA implementations. And some of them have even tried to solve these problems with their in-house data science teams. But unfortunately, the emerging technology of machine learning applied to this problem is simply unable to get the job done for the most part. So, the classic approach to solving this problem, I'm sure everyone here has experienced or played with this technology, is called an OCR template. And basically what you do is you take an example document, you draw boxes around it and tell it where to look for each field. Of course, in reality, forms never quite line up the way we had hoped. And as you can see from this example, an OCR template that's set up on one document rarely works for the same document with a slightly different orientation. Things like rotation, skew, layout changes make the problem a lot harder. And in reality, these solutions never actually work at scale. More recently, some of the cloud providers have built pre-trained APIs. So, Google, Amazon, Microsoft, et cetera, they now all have products that allow you to just upload documents and get the fields or other pieces of text extracted from them. So here's an example of that document uploaded onto one of those APIs. And it almost looks really great. The problem, of course, is that it misses a field state, and it misses part of the office phone number. And as a user, there's nothing you can do about this. It doesn't even report that the field is missing, let alone give you any ability to go in and actually update or change the model to reflect it. So what we see when we talk to customers is that these pre-trained APIs tend to work for some of the most common forms, like Accord 125 forms. Unfortunately, most real world forms are non-standard, and they just don't work out of the box. So, with an API-based solution, if you miss even a single field, you're completely out of luck, and that's very likely to happen unless the API was trained over your exact form, which again is pretty rare unless you're using a very standardized form.
Hey, Ankur, since I invited questions, there's a question already. Is this a one-to-one replacement for an app like Teleforms?
I'm not familiar with teleforms specifically, but just guessing from the name, it very well might be. If that's an open text product, yes, we have helped a few customers, including one who I named and quoted at the very beginning of the presentation, move some of these workloads off of the sort of legacy open text stack onto ours. Thanks for the question, and look forward to chatting some more about that too. Now kind of comes the fun part. These problems are fundamentally statistical, and they actually benefit from machine learning. Unfortunately, rolling your own machine learning solution is also pretty complicated. You need to spend a lot of time gathering and labeling sample documents, which you can use software like Snorkel potentially to actually help with nowadays quite a bit. But then you need to go and train a model and go and actually deploy it. And this ends up being a lot harder than advertised. So, you go and sort of train a model, deploy it, but then you're stuck in a constant loop of training and validating results, realizing things don't quite work, restarting. And then, of course, if the data or the form changes, then you often have to restart the process from scratch. So if we zoom out for a second and think about this kind of in an ideal world, the process should actually be really simple. You really should just be able to upload files, define the attributes that you care about, or even let the system propose a bunch of attributes that you might care about, and then do whatever you want with the data. I'm a database nerd, so anytime I think about playing with data, I use the word query. So if you see that throughout the presentation, that's why. But all the ML training and data manipulation stuff should just work without any effort. Actually, if you look at my T-shirt, I don't know if you can read it on the camera, but that's one of our phrases at Impera that we talk a lot about. And if we think about it further, this has actually been done before, but for a different kind of problem, which is the problem of working with structured data. In a relational database, if you're working with structured data, you just define a table, you set up the columns and indices that are relevant to your workload, and then you do whatever you want in SQL, and the software just works and figures out the rest for you. Things like B-tree indices are really magic, I think, for users, because you don't need to think about how to update them, how to recalculate them, how to worry about statistics or any of the information that goes into using them effectively. The database takes care of all of that for you. So at Impera, we basically asked the question, what if you could do the same thing with documents? Well, first you need something to hold them together. People don't think about tables as a way of collecting together documents, so we use the term collection. The second thing, and this is what we'll talk about for the sort of technology portion of this, is something we call an AutoML index. AutoML is a pretty familiar concept. It's basically the idea of automatically training and keeping a model up to date for you. We basically take that one step further and produce an index, so you don't need to worry about running or updating the model yourself. And of course, we make the data really easy to explore and query. So we have a spreadsheet UI and a REST API, and actually a pretty powerful query language under the hood that lets you ask what's the data for a single document, but also do some much more interesting things like run a group by query or join the data in documents to some structured data that might be relevant. So here's a quick video of what that looks like in the Impera product, just to give you a flavor for the user interface that you can produce with these technologies. And as you can see, all the user does is highlight the fields that they care about, and the system figures out the rest for them. And then if we open this other document, the fields are already highlighted for us.
Hey, I'm sorry, you typed in the first field and then it automatically picked up the second fields, or was that you were going into an existing one already?
Good question. So I highlighted one sample of the first name field and one sample of the last name field. So I told it about the existence of those two fields with just a label for each one. And it was able to use just that small amount of information to infer the first name value and the last name value for the other documents. I'll just play it again for those that want to see.
Anko, the example you're using is relatively a clean sheet and fairly simple fields. The commercial example I'll give you is I have a client with 10,000 vendors and every vendor has a different looking invoice. Are you saying you could apply those same rules with that same confidence, because the quality of the document is nowhere near as clean as you're using it?
No, that's a great question. I'll give you kind of the quick answer, and then maybe we can talk about it a little bit more in the Q&A part of it as well. But at Impera, the way that we think about it is that as a user, you should be able to iteratively provide more information to make the underlying model understand the documents that it's operating over. And so you're absolutely right. This example demos really nicely, because with just one label, I'm able to provide enough information for the system to extract every value for the field. In scenarios like multi-layout scenarios, it depends. Things like the total from an invoice are actually pretty easy because they're often roughly in the same place geometrically in an invoice, and they're often surrounded by vocabulary that's similar from document to document. And so in cases like that, one label might not be enough, but maybe just a few labels are enough. What we think about at Impera is how do we let a user just try providing one label and see what happens, and then continue playing with the system and teaching it more and more as they need to. And I think that question is actually a great segue into the technology part, and I'll talk a little bit about how this AutoML Index idea works. So just as a recap, AutoML is a really well understood idea, and basically the concept is provide some data and some rough guidance about what you're trying to do, and let the model deal with let the system deal with defining the model, tuning the parameters, and all the complicated stuff. At Impera, we've basically built an AutoML document extraction model that understands how to extract structured and semi-structured data fields from documents. We then take it one step further and automatically index the inferred values for you. So you don't need to worry about things like retraining the model incrementally when new data arrives, or running the model when you have new documents that you want to index. And the last thing I'll just mention on this is there's some algorithms. We use a technique called streaming variational inference that can be incrementally trained as new labels arrive. And these algorithms, basically combined with the idea of AutoML indexing, provide a real-time experience like what you saw for training and inference. At Impera, our general purpose document model is streaming, and therefore it fits very well into this architecture. But since you're all technologists, I'm sure you're already you've already jumped the gun and realized that the same idea could apply to a lot of different problems that involve machine learning.
So when I think about like documents and learning them, I kind of want to set it up once and just let it go, right? So there's not a incremental learning period. For example, invoices, as one gentleman mentioned, that you just kind of want to continue it on after you've learned or taught the system. So is there a way in which you could go back, for example, and look through, set up the model, run through a bunch of the previous invoices, compare the extracted data against what was actually extracted to make sure the model works? Is there kind of that mentality? And then just kind of let it go forever?
Yeah, no, absolutely. So one of the things that we have in the product is a very simple way of reviewing the results of the model. And by default, every time you review the results of a model, you actually provide a little label like in this sort of batch that you see right here that can be incrementally applied to improve the training for the model. So if someone goes in and reviews a bunch of things and confirms or corrects them, that's actually really valuable data that will improve the robustness of the model itself. And then to your point about having consistent, predictable performance from the model itself, the model is just a piece of data that gets versioned and can easily be frozen so that you don't need to worry about variability as you run the system against random data or something that you don't want to actually influence the model. But that's very easy to sort of turn on and off. And actually, again, another question that segues well into the next few slides.
Hey, Ankur, I also want to just do a quick time check. I mean, I love the interaction, and my fault for inviting it during your presentation.
Yeah.
But I do want to make sure that we leave enough time for Q&A.
We're almost done. We're almost done. We're like 2 slides away.
All right, perfect. So if you want to just keep going, go ahead.
But I'm not going to take any more questions. Just to
we'll come to those in Q&A. Yeah.
Yeah. So really quickly, I just talked a lot about streaming algorithms and real time and updating live. But if you remember, a few slides ago said, hey, this machine learning stuff is actually really slow. And really the reason for that is, again, one part, the organizational problem of getting all the data and training them, devising the right model, et cetera. But another big part of it is actually the fact that machine learning tends to run and tends to be formulated on really large batches of data that update, really, if it's really frequent, daily, but usually much less than that. So the way that we think about this at Impera is to split the processing into multiple layers. Basically, there are a few pre-processing steps that are trained over very, very large data sets, like taking pixels and producing a raw stream of unstructured text. And then some models that are streaming and can function in real time that actually understand the specific model that you're working with. I'm going to rush a little bit through the last couple slides here, but the magic trick and why we're able to make this operate in real time is that we reformulate the problem of updating machine learning models into something that looks much more like defining queries over layers and layers of processed data. And basically, by expressing the logic of machine learning as a series of queries, we're able to disentangle the physical side of actually computing and training a machine learning model over batches of data from the logical side of expressing how documents relate to each other and how to extract information from them. The magic database trick, and this is basically the same idea as keeping a B tree index up to date as new rows arrive is called incremental materialization. And so the relationships between layers and layers of machine learning models are expressed as queries. And at Impero, we've built a really robust incremental materialization system that's able to basically take new batches of data and automatically recalculate all the little pieces that need to be recalculated. And sitting on top of all of this is a query layer that basically hides all of that away from you. And so the query layer automatically understands how to read from different levels of materialized data and backfill log events as necessary to actually complete the query consistently. So just really quickly, what that looks like in the product, if you upload a new document, you can see that everything fills in really quickly, including the labels on the document itself. And this is the last slide. Just a quick summary of us and how we think about it. Basically, our thesis is that problems like document extraction are really well understood ML problems that are pretty well solved at this point. They're just way too hard to implement. And we think this is generally true of emerging technology in the area of productivity. And from our perspective, there's a missing technology layer that makes AI and ML dead simple to use. And that in and of itself is a really hard technology problem. And that's what's driven us to build technology like AutoML indices and incremental materialization to make this process really, really simple. And that's really what we're all about at Impero. We're wake up in the morning and get excited to solve the technology problems that make AI and machine learning today in the context of document extraction, and tomorrow for a lot more things, really just dead simple for people to use.